Before we look at the first question here on quadratic equations, we first need to look at something called the zero product rule. So the zero product rule. Now, the zero product rule says the following. If A times B equals 0, then A is equal to 0 or B is equal to 0. In other words, when we multiply two numbers and we get an answer of 0, one of them must be 0. So let's look at the first equation here. In this case, we have x plus 2 times x minus 3 equals 0. In terms of the zero product rule, the x plus 2 can be a, or the x plus 2 could be a, and the x minus 3 could be b. So a times b is 0. X plus 2 times x minus 3 is 0. And by this rule, it means that x plus 2 must be 0. In other words, a must be 0. Or x minus 3 must be 0. In other words, b must be 0. And now we simply solve each of these two equations. In the first equation here, we can take the 2 to the right-hand side, and it becomes negative 2. So x is equal to negative 2. Or, in this case, we can take the negative 3 to the right-hand side. So x will equal 3. So the answer or solution to this equation then is x is equal to negative 2 or x is equal to 3. Let's look at the second equation here. In this case, we have 2y minus 1 times y minus 1 equals 0. So the 2y minus 1 could be a, and the y minus 1 could be b, in terms of the zero product rule. So by this rule, we know that a must be 0. In other words, 2 minus 1 must be 0. Or b must be 0. In other words, y minus 1 must be 0. So we solve for y in the first equation here. We can take the negative 1 to the right-hand side. So 2y equals positive 1. And now we can divide the 2 into the right-hand side. So y equals 1 over 2. In this equation, we want to solve for y. So we can take the negative 1 to the right-hand side. And it becomes positive 1. So the two solutions then are y is equal to a half or y is equal to 1. Let's look at C. So here we have 5p minus 3 times 2p plus 7 equals 0. In terms of the zero product rule, the 5p minus 3 could be a, and the 2p plus 7 could be b. So we know that 5p minus 3 must be 0, or 2p plus 7 must be 0. Solving for p here, we can take the negative 3 to the right-hand side, and it becomes positive 3. And now we can divide the 5 into the right-hand side. So p is equal to 3 over 5. In this case, we can take the positive 7 to the right-hand side, and it becomes negative 7. And now we divide by 2. So we divide 2 into the right-hand side. So p is equal to negative 7 over 2. So p is equal to 3 over 5, or p is equal to negative 7 over 2. Then in question 2, we have to solve by factorization each of these equations. Let's look at A. Now, important to note that the left-hand side of this equation is a trinomial. It's in the form ax squared plus bx plus c equals 0, where a is the x squared coefficient, in this case 1. B is the x coefficient, in this case negative 4. And c is the constant, in this case it's negative 32. Also important to note that this equation here has an x squared coefficient of 1. In other words, a is equal to 1. When this is the case, we can use the following method to solve this equation by or with. We start with a constant and write down all the factors of it. So the constant here is 32. We can ignore the minus for now. So we want to write down the factors of 32. It's 1 and 32, 2 and 16, 4 and 8. So these are the factors of the constant. Now we look at the x coefficient, it's negative 4. Which set of factors will give us negative 4 when we either add or subtract? 1 and 32 can't give us negative 4, whether we add or subtract. Neither can 2 and 16. 4 and 8 can give us negative 4 if the 8 is negative and the 4 is positive, because 4 minus 8 will give us negative 4. Now we open brackets, and we have x times x will give us x squared, and we're going to use 4 negative 8, so positive 4 and negative 8, and this is equal to 0. Now we can use the zero product rule. X plus 4 times x minus 8 is 0, and that means that x plus 4 is 0 or x minus 8 is 0. And now we simply solve for x in each of these two equations. So here we can take the 4 to the right hand side, it becomes negative. And in this equation, we can take the negative 8 to the right hand side, and it becomes positive. Let's look at this equation. Once again, the left hand side of this equation is a trinomial. In other words, it's in this form, ax squared plus bx plus c, where a is equal to 1. In other words, the x squared coefficient is 1. So we can use the same method as before. We start by looking at the factors of the constant, in this case negative 84, although we can ignore the minus. And we need factors of 84 that when we add or subtract them, we get positive 17. So we know the factors of 84 will be 1 and 84, 2 and 42. So 1 and 84 won't ever give us 17, whether we add or subtract them. So we know this won't work. Neither will 2 and 42 give us 17, whether we add or subtract them. We also have 4 as factors of 84, 4 and 21. Now, 4 and 21 can give us 17 if the 21 is positive and the 4 is negative, because negative 4 plus 21 will give us positive 17. So now we open up brackets. X times x will give us the x squared. And then we have negative 4 and plus 21. And this is equal to 0. Now we can use the zero product rule. So x minus 4 is equal to 0. Or x plus 21 is equal to 0. In this case, we can take the negative 4 to the right hand side and it becomes positive. And here we can take the positive 21 to the right hand side and it becomes negative. Let's look at this equation here. We have x squared plus 18x minus 144 equal to 0. And we need to solve for x. We start by looking at the constant term. In other words, the term without an x in it. In this case, it's negative 144. We're going to ignore this minus for now. We want factors of 144 that will give us positive 18 when we add or subtract them. So let's start by listing the factors of the constant. So it's 1 and 144, because 1 times 144 will give us 144. Now, 1 and 144 can never give us positive 18, whether we add them or subtract them. So this won't work. In this process of finding the factors of 144, we can use a calculator. So 2 and 72 will be the next set of factors. 2 times 72 gives 144. Now, 2 and 72 cannot ever give us 18, whether we add them or subtract them. So this won't work. Then the next set of factors will be 3 and 48. And as I mentioned, you should use a calculator here. 3 goes into 144, 48 times. 3 and 48 cannot ever give us positive 18, whether we add or subtract. Let's try 4. 4 goes into 144, 36 times. But 4 and 36 can never give us positive 18. Then 5 doesn't go into 144. And we can check it on a calculator. So let's try 6. 6 into 144 goes 24 times on a calculator. Now, 6 and 24 can give us positive 18 if the 6 is negative and the 24 is positive, because negative 6 plus 24 gives us positive 18. So now we can write down our brackets. Then x times x will give us x squared. And we saw that negative 6 and positive 24 will work. So x minus 6 in the first set of brackets, and an x plus 24. Now we can use the zero product rule. So x minus 6 is equal to 0, or x plus 24 is equal to 0. And now we solve for x in each of these two equations. So in the first equation here, we can take the negative 6 to the right-hand side, and it becomes positive 6. In the second equation here, we can take the positive 24 to the right-hand side. So x will equal negative 24. Let's look at question 3a here. We need to solve this equation, which is a quadratic equation, by factorization. Now, before we look at how to solve this equation, something very important. Whenever we want to solve a quadratic equation, we always first want it to be in the form ax squared plus bx plus c equals 0. This is known as standard form. So in standard form, we first want to write the term in x squared, then the term in x, and then the constant. Now, clearly, this equation is not in standard form. We want to rewrite it so it looks like this. So first, our term in x squared, which is negative x squared. So first our term in x squared, so minus x squared. Then our term in x, which is negative x, or negative 1x. And then our constant, which is positive 6. Now this equation is in standard form. Then another thing of importance, whenever we want to solve a quadratic equation by factorization, we want the x squared term to be positive. So we want to get rid of this minus here. We can do so by multiplying the equation through by negative 1. So a minus times a minus here is a plus, and we end up with x squared. A minus times a minus here is a plus, so plus x. And in a minus times a plus is a minus. Now we are ready to factorize the left-hand side of the equation. Now we want to look at factors of 6. So the factors of 6 are 1 and 6. And 2 and 3. We're looking for factors that when we add or subtract them, we get positive 1. Now, of course, here, 1 and 6 can never give us positive 1, whether we add or subtract them. 2 and 3 can give us positive 1 if the 2 is negative and the 3 is positive, because negative 2 plus 3 will give us positive 1. So now we can open our brackets. Then x times x will give us x squared. And inside the brackets we can now write minus 2 and plus 3. Now we can use the zero product rule and solve for x. So x minus 2 is 0, or x plus 3 is 0. And solving for x here, we get x is equal to 2, or in this equation, x equals negative 3. Let's go on to b. Now, this equation is not in standard form, or it's not in standard quadratic form. Remember, standard form looks like this: ax squared plus bx plus c equals 0. And clearly, this equation is not in this form. So we first want to write this equation in standard form. Now, we can start by multiplying out the brackets. So we're going to multiply x minus 3 by x plus 1. So x times x is x squared. X times 1 is 1, or 1x rather, or just x. Negative 3 times x is negative 3x. And negative 3 times positive 1 is negative 3. We also want the right-hand side of the equation to be 0. So we can bring the 12 to the left-hand side of the equation. And this equals 0. Now we add like terms. So x minus 3x is negative 2x. And negative 3 minus 12 is negative 15. Now this equation is in standard form, or standard quadratic form. We first have the term in x squared, then we have the term in x, and then we have the constant. So we can proceed to factorize. We're looking for 15, or rather factors of 15, that when we add or subtract them, we get negative 2. So what are the factors of 15? It's going to be 1 and 15, and 3 and 5. 1 and 15 can never give us negative 2, whether we add or subtract them. So this won't work. 3 and 5 can give us negative 2 if the 3 is positive and the 5 is negative, because positive 3 minus 5 is negative 2. Now we can fill in the brackets here. So x times x will give us x squared, and we're going to use plus 3 and minus 5. Then using the zero product rule, x plus 3 must be 0, or x minus 5 must be 0. And solving for x here, we can take the 3 to the right-hand side and it becomes negative 3. We can take the negative 5 to the right-hand side and it becomes positive 5. Then in question 3c, we have to solve this equation. Now, this equation is clearly not in standard form or in standard quadratic form. Remember, the standard form is ax squared plus bx plus c equals 0. Now, we need to first write the equation in this form, in standard form. And we can start by multiplying out the brackets on the left-hand side. So x times x is x squared. X times positive 1 is positive x. Then negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. We can also multiply the 3 into the brackets on the right-hand side. So 3 times x is 3x. And positive 3 here times positive 1 is positive 3. Now we can add like terms on the left-hand side. So positive x minus 3x is negative 2x. Now we can bring all our terms to the left-hand side. Remember, we want 0 on the right-hand side here. So x squared minus 2x minus 3. We can bring these terms to the left-hand side. So 3x we bring to the left-hand side, it becomes negative 3x. This positive 3 here, we bring to the left-hand side, and it becomes negative 3. And this is now equal to 0. Now we can add like terms on the left-hand side. Negative 2x minus 3x is negative 5x. And negative 3 minus 3 is negative 6. This is now in standard form, or standard quadratic form. So now we can factorize. We want factors of 6 that when we add or subtract them, we get negative 5. So what are the factors of 6? It's 1 and 6, and 2 and 3. Now, 1 and 6 can give us negative 5 if the 1 is positive and the 6 is negative. Can 2 and 3 give us negative 5? Yes, if both of them are negative. So now the question is, which set of factors will we use? We can answer that question by looking at the constant here. We know that when we multiply these numbers, we must get negative 6. Now, negative 2 times negative 3 will give us positive 6, and we want negative 6. So this won't work. A plus times a minus here will give us a minus over here. So we're going to use plus 1 and minus 6. Then x times x gives us x squared. And then we're going to put in plus 1 and minus 6. Now we can easily solve the equation, or solve for x. Using the zero product rule, x plus 1 is 0, or x minus 6 is 0. Solving for x here, x will equal negative 1, and here x will equal positive 6.